Hey guys, Mr. Yisley here. So we're on to the next section where we're going to learn all about graphing linear inequalities into variables. Now, in order to be able to graph a linear inequality, the first thing that has to happen is it has to be in slope-intercept form. So we have to have it in y is, and then again, any inequality symbol, we're going to use greater than mx plus b. If it's not in that form, you need to get it into that form, which is what we covered in the last lesson. All right, and how we graph this is really no different, all right, than we did before, all right? We're going to use the y-intercept in order to graph it. We're going to graph that point first, and then we're going to use the slope. And so we have a little adjustment to make here. It says graph the line using the point in the y-intercept. That should be cross out point and write slope. So that should be graph the line using the slope and y-intercept. So again, we start with the y-intercept. That's always going to be our first point that we graph. All right, so we start with that y-intercept. Then we use the slope and we determine what does it tell us to do. Does it tell us to go up and to the right? Does it tell us to go down and to the right? What does it look like? So that's always going to be our next spot that we do. All right, is we'll use the slope to create two more points. All right, so the y-intercept, start here. That's your first point. Your slope, you create two more points off the y-intercept. So that's not new information. You've already learned how to do it. Simply being in an inequality does not change how you graph the line itself and how you use slope and y-intercept. Now, where things are just slightly different and we need to pay attention to is if you have a less than or greater than symbol, but no portion of an equal sign, it is a dashed line. Right? So if it is a greater than or less than symbol, but there's no portion of an equal sign, it's known as a dashed line. And dashed lines look like this. So if we had our line here with arrows at each end, and this is a sloppy one, but this is what it would look like. All right? It's going to look like dashes. They're not connected, all right? But they still do kind of form a little line. Now, if you do have a portion of an equals to sign, so like a less than or equal to, or a greater than or equal to, that's going to be a solid line. So that's going to look exactly like it did before. We're going to have the arrows at each end and a line connecting those arrows straight through. Make sure you're using your ruler. All right. Our second step after we've graphed the line, we've figured out if it's dashed or solid, and we've drawn that, right, is then we use a test point, right? And a test point cannot be on the line. Now, when I say test point, we're saying an ordered pair, right? And it can be any point on the graph that doesn't fall on one of the lines. So it's got to fall on one side or the other. My recommendation to you is use the test point 0, 0 if possible. All right, and we'll talk about why when we go through these, all right? But 0, 0 would always be my recommendation, all right? If you can't do 0, 0, I would encourage using another one with a double number, so things like 1, 1 or 2, 2. All right, and the reason for this is we have to remember that when we're plugging in an x and a y coordinate, right? And we're going to put those in for x and y. So if the number is the same for x and for y, there's no chance that you plug the wrong number in, right? If they're both 0, I can't accidentally plug the x in for the y or vice versa because they're the exact same number. So anytime we can, or we want to use 0, 0 as our test point, all right? But if it falls on the line, because we cannot use points that fall on our line, then let's try to find a point that has the same. Now, that's not a requirement, that's just a recommendation. All right, once we plug that test point in, we're going to figure out, does it make the inequality true? All right, so does it make that inequality true? Do we end up with 3 is greater than 2 or something along those, along that side? If it is true, then we shade the half of the graph where the test point lies. All right, so if it's above the line, all right, and that's where our test point fell, and we plug it in and it comes true, then we're going to shade everything above the line because that means everything up there is a solution. if the test point comes out and it's not true, so we end up with something like 2 is less than 3. All right, so in our original example, we said we ended up with something like 3 is greater than 2. All right, if that's true, shade that half. Maybe we end up, though, with something like 2 is greater than 3. Well, that is not true. That's false. All right, so that means everything on the side that the test point is on is not where we shade. All right, we shade on the side without the test point. So shade the half of the graph without the test point. So that may be below the line, it could be above the line, could be in a few different places. So that's the basic process that we're going to go through. All right, so this is some basic intro information. Make sure you've taken good notes on this because we'll refer back to this when we go through our examples. But otherwise, you should have what you need to continue on to the examples.